Here we're going to do rational root theorem again. And I want to know what are the rational roots for 3x to the third, 7x squared, 6x minus 8 equals 0. So, applying the rational root theorem, we need to find factors of p, which is our constant term, and factors of q, which is our leading coefficient term. So, factors of p are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. And then factors of q, plus or minus 1, and just plus or minus 3. So, our possible rational roots can be in the form of x equals plus or minus p over q. So, let's find all possible p over q. So we can have plus or minus 1, plus or minus 1/3, plus or minus 2, plus or minus 2/3, plus or minus 4, plus or minus 4/3, plus or minus 8, plus or minus 8/3. So these are all the possible rational roots we can have that satisfy the polynomial 3x to the third plus 7x squared plus 6x minus 8. Okay, now we actually want to find the actual roots. So the actual rational roots, this is guess and check with the calc. So we want to enter our polynomial into y1. So we want to enter into y1. So let's do that right now. So it's 3x to the third plus 7x squared plus 6x minus 8. So to check our possible roots, we're going to have to hit second trace value 1, enter. It'll graph. And looking at the graph, you notice there are no negative roots. The graph does not cross the negative x-axis. It crosses the positive x-axis. So each one of these dots is 1, so we know that we're going to cross between 0 and 1. So we want to check all fractions between 0 and 1. So all fractions between 0 and 1. So it's not going to be 1, it's not going to be 2, not going to be 4, not going to be 8, 8/3, 4/3. So now we're down to 1/3 and 2/3. So it's positive rational root only. Why? Because it crosses positive x-axis only. I should say the graph does. And again, the graph crosses the positive x-axis. It's the only intercept that we see. Therefore, it's the positive root. So the only positive roots are, we got to check positive 1/3 and positive 2/3. So let's check positive 1/3. So we're going to enter 1/3 and hit enter. You know it's not 0, so we're going to check the 2/3. So 1/3 is not a root. So we're going to check 2/3. And we notice that 2/3 does equal 0 for y, therefore 2/3 is a root. So the only possible rational root is 2/3.